Today we are on 2.4 and that's average rate of change. So our learning target here is to calculate the average rate of change of a function given its table, its equation, and its graph. So average rate of change, what in the world is it? Basically the average rate of change is the change in y over the change in x. So we can go ahead and we can have some ordered pairs here. So if my ordered pair is, my x value there is a, then its corresponding y value there would be f of a. And then if the x value there is b, then its y value b, you can take b and you can plug it into your equation there, and you can get f of b. So basically, up here, you know, we do f of b minus f of a all over b minus a. Basically, you're taking y2 minus y1 all over x2 minus x1. So that's all we're doing in that. We're just simply finding the slope. The average rate of change, think about finding the slope each time. All right. And also the average rate of change is the slope of a secant line between x equals a and x equals b of the graph of f. That is a line that passes through those 2 points. So that's exactly what we ended up doing there. You have a line there, it's that blue line on there, that's the secant line, it's going through those 2 points there. So you subtracted the y's over subtracting the x's. So the average rate of change of this function, so again that dashed line that's in there, that's called the secant line. We want to find those 2 values there so we can find the slope of those that going through those points there. So let me go ahead and do that for you here. So thinking through that, that top point there on the y-axis up there is sitting up there at 0, 7. And then that ordered pair down there at the bottom, counting those, looks like 4, 3. So we can find our average rate of change there, so we can say y2 minus y1 all over x2 minus x1. So in other words here, for ours, we can go 3 minus 7, because those are the y values, all divided by 4 minus 0. Now could I go on the other direction? Sure. If I would have done 7 minus 3, then I would have done 0 minus 4. So I get negative 4 over 4, which basically gives us a negative 1 there. So our average rate of change there would be a negative 1. So now let's figure out our average rate of change from a graph again. So we get, notice there your dashed line is going through those 2 points there. So that's what we want to find, the slope of that line there. So pick the points that are on there. They gave you some nice points there. So the one down there on the x-axis down there is sitting there at negative 4, 0. And the one up over there on the right-hand side is sitting over there at 5, 2. So if you find our average rate of change here again, what are we going to do? We're going to take y2 minus y1 all over x2 minus x1. What does that mean? That means I'm going to take 2 minus 0 all over 5 minus a negative 4. So that minus a minus there is going to become a plus. So basically we get 2 ninths as our average rate of change. So again, we got one more graph here. So you can see that dashed line is going through those 2 points there. So there's one over here on the y-axis over there. Or near the y-axis, it's sitting over there at 1, 4, I guess. 1, 4, right there. So that ordered pair there is 1, 4. Then there's one sitting way over here, and that's way up there at 7, 9. So again, find your slope, y2 minus y1 all over x2 minus x1. That gives us 9 minus 4 all over 7 minus 1. So we end up there with 5/6. So now we've done graphs there. Now we've got what happens now if we just have the function and then some values to go with it. So no graph this time. So this time you can just substitute your 1 into your function there since we've got our function there. So let's do that. Let's find f of 1. So I can just simply plug it in there. 1 minus 3 squared. Remember, you do your parentheses first and then square it. So a negative 2 squared is a negative 2 times a negative 2, which gives us 4. You plug that into your calculator and make sure you put the negative inside the parentheses there. And then if I find f of 3, that ends up giving me 3 minus 3 squared. Taking care of the parentheses, I get 0. And I square that, I get 0. So now I can take y2 minus y1 all over x2 minus x1. So basically when x is 1 here, we get a y value there of 4. When x is 3 there, we get a y value there of 0. So if I subtract my y's over subtracting my x's, I end up getting a negative 4 over 2, which gives us a value of negative 2. So my average rate of change there is negative 2. And we could do the same thing here with part B. I can go ahead and find f of 4. So I can go ahead and plug 4 into my function there. 4 minus 3 is 1, and then I square it, following the order of operations, and I get a value of 1. So when x is 4, my y value there is 1. F of 7, I could do 7 minus 3 squared. 7 minus 3 there is 4. Square that, we get 16. So when x is 7, y there is 16. So now we can do it again, y2 minus y1 all over x2 minus x1. So I can take 16 minus 1 all over 7 minus 4, which gives me 15/3, which gives me 5. So given the function, we can go ahead and figure out the y values that go with it and calculate the average rate of change. Now what happens if they just give us a table of values here? Well, if they just give us a table of values, we can figure out what the y values that go with it. So they said at 8 a.m. there, the temperature was 38 degrees. At 9 a.m., the temperature there was 40 degrees. I don't think that's a 38. Let's try it again. So again, no difference. You subtract your y values, 40 minus 38. And then you got to be careful with time here. 9 a.m. minus 8 a.m. Now those you can subtract and you get a 1. So you get 2 over 1, which gives you 2 degrees per hour. And so that's what our time that went by there. And so then 1 p.m. at 1 p.m. there, we end up having 62 degrees. At 3 p.m., looking at the table there, is 67 degrees. So I can subtract my temperatures over subtract my time. And again, sometimes you can't directly substitute them because you got AM and PM together down here. So we end up getting 5 degrees per 2 hours, but we want it degrees per 1 hour. So really that would be 5 divided by 2 there is 2.5 degrees per hour. So again, just calculate your slope. There was degrees, and we want it per hour, so we had to do 5 divided by 2 there, which is 2.5 degrees per hour. So let's go ahead and find the average rate of change of a function between the indicated values of its function. We did that. So we can calculate the average rate of change of a function given its table, calculate the average rate of change of a function given its equation, and calculate the average rate of change of a function given its graph. So on page 179, 13 through 26, 31b, 32b, and 33b.